Hello, everyone. So I think we have our speaker here. So Harsh. Uh, Hi, everyone. I think we have our speaker here. So Harsh is actually a Purdue graduate. He obtained his bachelor degree and PhD degree from Purdue in industrial engineering. And then Harsh is currently working as a product manager for Google. And Harsh, are you ready?
Hey, how's it? Yeah, I'm ready. Just a quick thing. Is this all online or is it being done in a classroom in Purdue?
It's all online. So
it's all online. Okay.
Yep.
Well, I don't know how comfortable people are with their cameras, but it'll be great to see actual human beings if you are comfortable opening up your camera.
Yeah, anyone who is comfortable, to do the video, I can do it. So, yep.
Okay. Now I know I'm talking to somebody. Perfect. I just need share screen access. I don't have that.
Oh, you don't have that? Let me do it. I think you should be able to share it right now.
Yeah, works. 1 second. Please let me know if you can actually see the slides.
I can see it.
Okay, perfect. So I can start. First of all, thank you so much for inviting me here. And I see some names that I already know. Hey, Professor Proctor, thank you for joining. And Yashin, long time, we need to catch up. So just to start with, once again, thank you for inviting me to talk today. As you can see, I still cannot spell well. The title of my presentation today is You Really Can't Be Serious About That, Judgment Analysis and Producer Management. And I'll explain why it's not called product management. To give a quick background, I did my bachelor's, master's, and PhD from Purdue. And after that, I worked in multiple places, but currently I'm working for Google Cloud Platform. So it's the Google's cloud version, and I'm a product manager there. Before this, I was a mixed methods user experience researcher at Google. This is a disclaimer that I need to give for all my talks. All the views expressed here do not belong to my current or previous employers. I have to name them. So whether that's NASA, Google, Schlumberger, or Leidos. So everything I'm saying, it's just what I think. To summarize the talk, today I'll be talking basically about my research in the field of judgment analysis. Specifically, and I investigate the effects of information on human judgment. I use actually human in the loop protocol, right? Experiments in my research and study the effects of on humans as part of the overall system. So today I'll be presenting one part of the research, specifically focusing on the effect of quantity and representation of information on human judgment while actually using a judgment model. In the end, I'll conclude that the quantity of information, right, and the representation of information does not affect the judgment for novice judges. So since this is a research talk plus more business talk, there cannot be any surprises. So if you want to leave, this is the best time to leave the talk. That's the end result that I'll be talking about. Going slightly in depth, the outline is I'll start with a little bit of motivation that why I wanted to do this, then problem definition, going over with the study that I did. I'll be discussing a quick experiment that I did with the results and conclusion, and then we'll go for what is also the fun part for me is go into business and how this is actually done in business. Any questions until now? Okay, perfect. If anybody has any question, please just unmute yourself and speak up. Okay, so the main premise, people make judgments all the time. One of the judgments that you all actually have to make, should we go to the talk today or not? So that's actually a judgment that you make. Right? Another judgment, for example, some of you have gotten a car, you have to make a judgment. Hey, you want to buy a car, what should be the actual price of the car that we are ready to pay, right? So a customer would make a judgment about the price of a car after analyzing multiple things. So let's do that study here. If you have to figure out the cost of this car, what do you think in your mind? Think about a cost for this car. And after you've thought about it, if you can, just put it in your chat. What do you think is the cost of the car?
Got to know this part.
Harsh, can you elaborate, like what are the aspects?
Sure.
Mhm.
So there are no aspects. Just you are at a dealer, you're looking at this car and you are making a judgment call on what should be the cost of this car. That's it. You just have this in front of you.
Then maybe the module and the miles.
I have no idea right now. That's it. That's all you have.
The best guess I have is, yeah, maybe these two would be my best guess to estimate, to make judgment.
Okay, but what if you don't have? What if just that's it? That's all you got here, right? What would be your best judgment for the cost of the car? And there is no correct answer. Just feel free to type in
The brand
manufacturer,
yeah, the brand of the car.
the brand.
Okay. Yeah. No, you guys are all saying the right thing. So okay, Maya has $55,000. That's what I'm looking for a number. What do you think? Just by looking at this, nothing else. Whatever you can gain information you can get from looking at this picture, that's fine. But just give a best estimate of what's the cost of this car. 70,000. Okay, 60,000.
I have no idea about cars.
No worries. If it looks good to you, right? I mean, I'm not showing my Toyota Camry. It looks slightly better than that. So just any estimate. Okay, perfect. So we have 60 and then we have 72. That's very good. So now you all have thought of a number and you are giving me some number. That is great. What about I give you some more information about the car, exactly what Yashin was asking. How about I give you these pieces of information? I show you a picture of the car. I tell you the brand of the car. So this is actually a Mercedes-Benz. I tell you two more pieces of information. I give you the mileage for this car, and I actually give you the resale value. How about you go out in the market after 3 years? What's the resale value for this car? I tell you it's a 4-door. And I also tell you the person who's the brand ambassador for this car is Roger Federer, and he recently retired.
What the fuck?
That's an emotional thing for me, so I have to mention. But
Did he retire? Sorry.
Yes, I know. I don't know
Oh,
if you are not a Federer fan, but he just retired.
Yeah, you do.
oh,
So if these are the pieces of information for you, so the mileage for this car on average highway and on the road, it's around 25 miles per gallon. The resale value for this car is around $35,000. After 3 years, it's a 4-door, and Roger Federer is actually a brand ambassador for this car. So now, what do you think your judgment would be for the price of the car? So people who have put in a number before, if you want to change it, just go ahead, put another number. If you don't want to change it, just put same. Or anybody, you want to put the price of the car now, go ahead, put up your numbers. Okay, so Maya said same. Strawberry said 80,000, so it bumped up from 50 to 80. Howzy said same. Yashin, what about you? You asked for some things to consider before. Okay, $100,000. Okay.
I see an investment chance if this is really coming from some famous people, owned by some famous people.
So, by the way, Roger Federer is the brand ambassador. It's not that you are getting his old car.
Oh, come on. Then I will not, I'm not trying to get this one. No way.
Okay, so you see what's happening, right? I gave you cues. So I gave you some more piece of information to work with to make a judgment. This is what I'd be calling as cues in a judgment making model when you are trying to make a judgment about something and I give you cues or available information. Next up, if I'm telling you the mileage for this car, for example, if I tell you that straight up the mileage for this car is 30 miles per gallon, or I tell you that the mileage for this car is between 21 to 39, do you think that would actually affect the price of the car? So just think about it. I gave you the mileage, but I can either say 30 or I can say 21 to 39. I'm giving you a range for the mileage. So what am I doing in this case? I'm giving you a piece of information, but I'm changing the certainty of that information. I'm representing that information in a different way. In first example, 30 miles per gallon, it's a sure shot number, right? There's a 100% guarantee that it's 30, but I represent it in a different way. I give you a range 21 to 39. If you actually compute an average from 21 to 39, you will come to the same number 30, but still it's not sure, right? It's a representation for that Q. One piece of information is changed. Now, my question is, does changing the representation of a Q, does it affect a human judgment? Would it actually matter how I'm representing that information? Anybody has any comments on that? Okay. So moving along.
Hush, I have a question about this. So you mentioned about like by showing the representations, it might influence the, let's call it the judgment. So does the judgment here implies there is an underlying construct that is stable within every, like, let's say viewer or user? Is that the judgment we are referring to, or you are more about we are more about like referencing some concept that is fluctuated values that can be mediated or moderate by some factors?
Okay, so in this example, thanks for the question, Yashin. So did everybody get the question? Because it was pretty clear, so I've not repeated. If not, please let me know, I can repeat it. In this case, the judgment is your personal judgment. What do you think is the price of that car? And it is just depending on what you consider as important. You can look at those things or the cues, and then you are just coming up with a number. So that is all I mean by judgment. So a very simple example for judgment is if you have to make a decision whether you should take an umbrella out when you're going to college, for example. Would you take an umbrella or not? So you are making a judgment for that. And now you can make a judgment either to take the umbrella or you can make a judgment on not taking the umbrella. So I'm calling it judgment. In many models, people call it decision making. You're just trying to make a decision. When you have multiple choices, you're making a decision. In this, I'm calling it judgment because it's dependent on the judge, on you. So everybody else in this audience, right? We are all different judges and everybody came up with a different value for that. However, in this case, when I'm saying judgment, there is an absolute truth. So you all came up with different prices of the car, but there is an actual cost of the car, which is the true value. You are just trying to judge what is the value according to you, but there's an absolute truth. So in the case of umbrella, whether you should take an umbrella or not, If it rains and you have an umbrella, you have a good judgment, right? So that's what it is.
Okay, I see. So it's more about like there's a ground truth. However, our personal, like if we are making judgment, it's basically like making decision, and that situation is situated.
Yes.
Oh, got it. Got it. Thank you.
Yep. Okay. Perfect. So the actual price of that car, so it actually fluctuates. The price of this car is around $56,000. So people who got it close, I don't know, I think the name of the show is Jeopardy or something. I hope I can actually gift you this car, but I don't have that kind of money. So I think the person who got it closest was Ryan, was 60, and Strawberry, I'm sorry, you went up to 80, and Yashin, you were 100,000, and then you just didn't even put the cost price on the car. So that is the true ground truth for that car. But as I'm changing the number of cues I'm giving, and as I'm changing the representation of the cue, the judgment is changing for you guys. Now, is that really important in industry? Do we even care about these things? Let's see some examples. All of these judgment tasks are done every single day. You do it, I do it all the time. My wife did it when she was trying to make a judgment whether she should get married to me or not. And in industry, people do it. For example, for a treatment for a cancer patient, oncologists have to make a judgment how much area they should actually put radiation on if they want to target cancer cells. For a drone strike, there is an engagement area for a drone strike. So it's actually human judgment. We have all the tools available, but after that, it's human judgment to decide on the engagement area for a drone strike, because you want to limit the collateral damage. You do not want to hurt innocent people or infrastructure. The next one example is investment portfolio. When you are trying to make your portfolio, right, and especially for a venture capital firm, they make a judgment which companies to invest in so that they can eventually come over the top for the market. And finally, one example that relates to me is time to launch a new product. So if you would have looked at recently, Google actually launched their new phone. Apple launched their new phone. I'm thinking probably some other companies will soon launch their phone. How do these companies decide when is the best time to launch a product? And that's just one example. We make these judgments all the time in our daily life, and it's used in industry. And all of these have big implications. So I'll just give you one little example for this, and to just show you why is it really important. So when I was telling the number of cues, right? How many cues do you really need to make a judgment? Imagine for a cancer patient, you can get a lot of data by actually subjecting the cancer patient to multiple tests. There are so many tests which are actually invasive, which can really reduce the quality of life for the patient. There are other tests that can actually increase their disease within them, just trying to figure out what is the right area for radiation. Now, every single cue actually is costly. So that is very critical. Do we really need that many cues to make a judgment, or can we make a judgment with fewer cues? And that is why was the motivation for the study. I wanted to understand how much information do we really need to make a judgment? Because every piece of information, it's not cheap. When you go to a dealer, you can always ask them, and that information is slightly cheap. But when you are making big decisions, we are talking about millions of dollars. Companies spend actually millions of dollars to do market analysis through consulting firms to get more and more information to make a judgment. But do they really need that information? And also the representation, right? They spend a lot of money trying to have pinpointed information. Can they really work with less accurate information or a different representation of information? If we can figure that out, it can have huge impact on the industry. So if that is clear, why it's important, this is the problem that I was trying to solve. We do not know how changing these following things affect human judgment. The number of cues, which is the number of pieces of information to make a judgment, and cue representation, how we represent that piece of information. So that's the problem that I was trying to solve. I came up with these hypotheses. First one, whether changing so first hypothesis is human judgment is not affected when the cardinality of the cue set changes, which just means number of pieces of information to make a judgment. And the second hypothesis was that human judgment is again not affected when representation of the cue changes. So whether you say 30, you say 21 to 39, or you give it more variability, I made a hypothesis that, okay, human judgment is not going to change. To solve this question, I looked at different models, and I finally settled on using Brunswick's lens model. So one thing is very good about Brunswick's lens model. It actually uses the same pieces of information to create two different regressions. So if you see on the left-hand side where it says environment, and you see the equation under it, it's actually a linear regression. So it's a multiple linear regression equation, right? And on the right side, it's again a multiple linear regression equation. So it's a very simple model, number one. Number two, in the center, you see x1, x2, x3, and so on. All of these are cues or the pieces of information. On the left-hand side, you see environment. Environment is the ground truth. This is the reality. So in our case, the value YE is that $58,000. It's the true cost of the car. So there is a ground truth, an actual value. YS in our case would be all the values that you all gave, right? That is your judgment. So YS is that number, your judgment, right? And X1 is Roger Federer is the brand ambassador. X2 is it's a four-door sedan. X3 could be that it's a Mercedes-Benz. So these are the number of cues. Now, how do we combine them? How do we figure out if that judgment is good or bad? Well, if you would have said $56,000 and the real cost of the car is $56,000, your judgment is perfect. So the achievement, the thing that I've circled, RA, that achievement is actually a correlation factor between YE and YS. So that correlation factor would be 1. That means perfect judgment. However, the more you sway from the true value, the more the correlation coefficient changes. So that's why I use this model. And a longer explanation of why I use this model is written here. It really, the main thing is that it helps me solve the question. It helps me come up with an answer to the question. And it helps me to prove my hypothesis wrong if they happen to be wrong, right? And there are other, there's a lot of other stuff about Brunswick's lens model. It has been used extensively in almost every single domain possible that we can imagine. And it has been validated numerous times. So this was one of the models that I thought would be the best fitting here. And there are other reasons I ran simulation studies to really validate this model. And that's why finally this was decided that I use this model. So before I move on to the experiment, how I set up the experiment to really check my research questions, does anybody else have any questions? Okay, so usually when I was in Purdue, silence in my class would mean two things. Either it's super clear, so everybody understands everything. And number two, nobody's paying any attention and we couldn't care less about what the speaker has to say. For me in the audience, usually it was the second case, but I'm hoping that for all of you, it's the first case. Everything is crystal clear. Okay, so let's go over the experiment. I actually used real data, which was the electricity usage from 2 fast food chains between 2007 and 2010. So what do I mean by actual electricity usage? So if you stay in an apartment in your house, you always get an electricity bill at the end of the month. That electricity bill is your kilowatt hour usage converted into dollar value. I actually had data from fast food chains, how much electricity is being used in that fast food chain for every single day from 2007 all the way to 2010. So fast food chain, this is not the real fast food chain value I had, but for example, it was McDonald's. I had that. On top of that, I had the things that affect electricity. So think about it. In a fast food restaurant, what are the things that will affect electricity? Anybody have any guesses?
Well, the number of consumers will affect that. Like it determines the amount of food you have to prepare, right?
Spot on. Absolutely.
And then,
what else? So do you think if it's snowing outside, it'll affect the electricity used in the store because they might have to turn on the heat?
Yeah, yes.
Right. And if it's super hot outside, so for example, if you're in Houston, they would need to turn up their HVAC, their air conditioning, to make sure that their patrons are not roasted as the chicken they're roasting, right? So they would need to use that. If there are more people within the dining area, they have to pump up the HVAC. And if they have a drive-through, but not that many people in the dining area, that they can turn off the lights inside the dining area. The amount of time the fast food chain is open. For example, if they are open only during the day, or they are opening during the night too. So they have to use more light, right? So more electricity usage. So there are some factors that directly affect electricity usage, and there are some factors that indirectly affect. I'm calling those things as predictors. So now I hope the model is trying to make more sense. Since I said the Brunswick-Lenz model is actually a linear regression model. So when we have a regression model, we need to have a Y or a response, and we need to have predictors, X1, X2, X3, or Qs. So these X1, X2, X3, those values are transactions, as Hauser said, right? Transaction means number of transactions they have in a store. What's the temperature outside? What are the cooling degree days, which just means how cold it is outside in a year. What is the kitchen rooftop unit, which means how big an air conditioning unit they have in their kitchen, how big an air conditioning unit they have in their dining area. And along with this, I had around total of around 26 predictors that affect electricity usage. So I had those values. Now I created this full factorial design. It was between subjects. My participants were 30 people between 80 to 50 years of age. And all my judges actually were novices, which means none of the people had any clue how to come up with an electricity usage. I did not go out and ask Centerpoint or some electricity company, their officials, to come do the experiment. And it's funny, there are a few people who are in this call who are actually my participants. So dependent variable, since we are talking about an experiment, what is a dependent variable here? It was electricity usage, something that the participants need to guess the value for. And the independent variables, the thing that I was changing, trying to understand. Number one was cardinality of Qs. So I had 3 levels. One time I was giving the participants 3 predictors. The second time I was giving them 4 predictors, and the next time I gave them 5 predictors. So I gave them 5 different pieces of information to come up with a value for electricity usage in a fast food store. The next independent variable, or the next thing that I changed, was the representation of temperature Q. So I told one of my variables, the predictors, was temperature. So I told the participants sometimes that on that particular day, outside it was 30 Fahrenheit. And for sometimes I told them on that particular day, the outside temperature varied between 20 to 40 Fahrenheit. So you see, I changed the representation of the Q. One time I gave them a sure value, one time I gave them a range.
IT project management. There is no IT project.
I'm sorry, is there a question? Okay. If you have a question, please unmute and speak up. I think somebody forgot to turn their mic off. Okay. So the third thing that I actually changed, and I did not talk about it early on, is Lenz model. The Brunswick-Lenz model is not just a linear model. I showed you the example for a linear regression model. It can also be a logistical model where you just don't have to put a number where you can say yes or no, right? So it can be a logistical model too. So I even tried using that where participants just did not have to come up with one value, right? And they can actually pick between 2 ranges. So this was my experiment. And to actually set this up, what I did a demo round where I gave participants 10 questions. And this is actually a baseline learning mechanism where my participants were shown 10 different questions. And every question I'm asking them, it's per day. So I'm asking them the electricity usage for that day. I gave them some cues and I told them to come up with a number. They gave me numbers, right? Okay, it's 20,000 kilowatt hours for that day. Once they gave me the value, I told them the correct value. So I was trying to anchor them. I was trying to make sure that they understand how, when the value of the cues change, how does the electricity usage change? Because I wanted all the participants to come to the same level. So that's why this was the baselining for a demo round for 10 questions. Then I did an actual experiment where I showed them 120 different questions. So it's 120 different times they had to make a judgment. And every single time it's changing, which means I'm changing the number of queues. I'm changing, obviously, the values are changing, and I'm also changing the representation of a queue. Once that was done, again, there was no time restriction for this. I did a post hoc study. I asked them the reasons for why they chose what they chose. So for you guys, let's try one thing. This is an actual question for one of the participants saw. If the average temperature, so let's pick any store, any fast food restaurant that you like, and think about that restaurant right now. If the average temperature outside is 89 Fahrenheit, the kitchen HVAC unit is 13 ton. So just to give you a perspective, what that means, the more the tonnage, the more electricity usage. So if I say 5 ton, it's using less electricity. If I say 13 ton, it's using more electricity. So we have 13. Average is around 8 in a fast food restaurant. And that's a HVAC unit in a kitchen. And we had 14,000 transactions in one day from that fast food restaurant. So now your job is to come up with what's the usage, how much electricity do you think was used in that store that day? And you have to give a number in kilowatt hours. So since you haven't done any baselining, I'll tell you that it's actually more than 15,000 kilowatt hours. And that's a lot of electricity usage, by the way. So now's your chance. Come up with a judgment for electricity usage. So you can put it in the chat. So I actually have a record. You can unmute yourself and speak up. But now's your chance to come up with a usage value. I do not have any extra credit that I can give you, but it would be awesome if you can come up with any number that you think. And again, it's more than 15,000. $20,000, machine, okay. 30,000, right? Okay, so how do we have 20,000? Anybody else? $23,000. It feels like the game show. Okay, how about it's more than 30,000? Okay, so more than 30,000 we don't have, we just have a flat 30,000. Okay, so this, if I just ask you a question, you would not have any idea how to answer this. And it's practically, if I look at this question, it doesn't make any sense to me because I'm a novice. I do not know how to judge it. So that's why I gave 10 questions to all participants and got them to a fixed baseline where they kind of understood what is the interaction between these queues and the actual usage value. So the correct usage value for this is around 38,000 kilowatt hours. And remember, this is actually per day of electricity usage. And we can change it to month, but this is per day electricity usage. So thank you so much for participating in this. Finally, so I did this baseline study. I did the actual experiment. And in the end, from after 30 participants, what I was able to conclude that human judgment is actually not affected when cardinality of the queue set changes. But again, remember, it was novice judges in control condition. The second one, I was able to, again, I failed to reject my hypothesis that human judgment is not affected when representation of the queue changes. So if I'm changing the temperature values, so in this case, I gave you 89 Fahrenheit. If I actually gave you a range of temperature, when I gave that to the participants, their values did not really change. So this was good for me to figure out, okay, I was able to fail to reject, but something that was more insightful was why people actually made these judgments. So out of 30 people, 28 actually tried to guess the values of all queues. So what does that mean? At the start of the experiment, I told everybody that the maximum pieces of information or queues that you can get are 5. But sometimes I'll only show you 3, sometimes 4, and sometimes 5. So when I showed them less than 5 queues, majority of the participants actually tried to guess the value of the missing queues, and then they tried to come up with their judgment. So even though I did not give them, they tried to guess the missing queues, and then they came up with the judgment. And when I gave them a range for temperature, all participants actually computed an average. They did not care about the lower limit and the higher limit. They just averaged it out, had one number, and they came up with an answer using that one number. So what they did was they nullified the effect of the representation completely. And if there is a missing Q, they were still trying to guess it. So this actually has some important bearing in work. So I'll go over some of them right now. Number one, for novices, if I change task characteristics, which means if I change the Q cardinality or the number of pieces of information, or if I change how I represent that piece of information, it doesn't really affect human judgment. So when you have novices, and obviously this is just one study, it might be safe to not spend a lot of resources to come up with more pieces of information because it would not really affect human judgment. The second, it's not that the judgment was not affected. Remember, my question was, is the judgment affected? I did not care if the judgment was good or bad, which means how close they were to the real value of the kilowatt hours. I just cared about if they had a judgment, did the judgment move up or down? I did not care about good or bad, so not accuracy. But when I measured the accuracy, when I increased the number of Qs, it did not change their judgment accuracy. So in real life, we might not need to spend so much resource to increase the number of Qs, just try to pump up the accuracy. Same thing, precise representation did not increase the accuracy either. So again, we have to spend a lot of resources for representation of the Qs. So in reality, might not be a good idea or might not be needed to spend that much. Finally, the judges, especially novice judges, they tried to guess the missing Qs. I'm sorry, did somebody have any questions? I heard something, that's why I stopped. So when giving fewer Qs to the judges, I gave them less than 5 Qs. The judges tried to guess the value of the missing Qs. And at least from the literature that I read at that time, it is only the novices that try to guess the value of the missing Qs. For many of these studies with expert judges, it has been seen, even if you give 10 Qs to expert judges, they do not care about majority of the Qs because they are experts. They know which are the Qs that are most important. They only care about those Qs and try to come up with a judgment. So one of the examples where it's done a lot is air traffic control, where air traffic controllers, when they have to figure out if there would be any LOC, like loss of separation or LOS cases, air traffic controllers use a lot of judgment. They have a lot of Qs available, but they only use selected pieces of Qs and they're experts. So that's what they use. Moving on in tech industry, but before I move on, does anybody else have any questions about this?
Actually, I have a couple of questions regarding your experiment. Can you go back to your method slide?
Yes. Is this one?
Oh, yeah, okay, here. So about the number of Qs, when you are manipulating the number of Qs, how can you make sure that like each type of Q is containing the same amount of information, that you are not manipulating other factors other than the number of Qs?
Okay, so if I understand your question correctly, you said how am I making sure that the amount of information in each Q is similar? Is that
right? Because like, how would you equate like the information, like if you give them 3 Qs or 4 Qs, and in another case you give them a different kinds of like 3 Qs or 4 Qs, how you equate those kind of conditions?
Okay, perfect. That's an excellent question. So in the experiment, what I did when I gave them 3 Qs, those 3 Qs were fixed. So this experiment that I showed you, these were always the 3 Qs whenever I gave 3 Qs. It was always average temperature, kitchen tonnage, and transaction. When I gave them 4 Qs, it was always those fixed 4 Qs, but obviously I changed the value because it was for a different day. And when I gave 5 Qs, I obviously gave them all 5. So that's how I controlled for that. Otherwise, you are spot on. If one time I give transaction temperature and cooling degree days, and the other time I give transaction temperature and kitchen RTU, I'm not able to keep that constant. So that's how I kept it constant. So when I fixed the number of Qs 3, I had the same Qs that I was given.
So when you're like, just for clarification, so you're saying that when you are giving like the providing one more Q added to the 3 Q condition, that Q is always the same kind of Q for all participants.
Exactly. It's the same kind of Q for all the participants. Exactly. So if it's cooling degree days, it is always cooling degree days for all the participants whenever I'm giving 4 Qs. However, the values for those are always changing, but it's the same type. And the next question is, how did I decide that these 3 are the best ones for 3 Qs condition, right? How do I decide which 4 are the best one for 4 Q condition? And I said I had around 26 or something Qs. How did I decide for those 5? So since this is a regression model, I actually ran a best subsets regression model for this to come up with when is the best regression model if I'm using 3 predictors, what is the best regression model when I'm using 4, and what's the best regression model when I'm using 5. That's how I could come up with these are the 3 Qs I should choose, and same for 4 and 5.
Okay, that's a good answer. And second question is about like your second manipulation. Like for example, the representation of the temperature Qs, because I'm not sure like the range, like the effect of providing a range rather than a value will change based on the absolute value of the value you provided. Like for example, if the temperature is pretty high, then it might not matter that much. But if the temperature is around like the freezing point of water, I wonder if that will change. That will have some other effects rather than just like increasing the range of the information that you're providing.
Yeah,
because
go ahead.
Yeah, sure. Yeah, I'm kind of finished. Yeah.
Okay, so that's a very good question. So one of the things that I did, I always added, it was always a change of plus minus 10, but that is an excellent thing that can be checked if increasing the range actually has an effect. And also, what is the midpoint, right, for that temperature? If, as you said, if it's very cold, and if I'm changing the range, or if it's not so cold, if it's like average temperature around 65 to 70, and I'm changing the range, what would be the effect on the judgment? So absolutely, that could be something that can be tested, but I did not test that. For this study, the range for my temperatures was around 30 to 95. So that was the range, and I always did plus minus 10 for those days. But that's an excellent thing that can be tested, and that might actually have an effect. And that can be seen from once we actually run the judgment model. You can see if the judges are actually indexing more on one particular Q. So if their weightage for one Q is more, that can be revealed by the results of the judgment model too. In my case, the participants were not indexing on any one particular Q. So for my temperature, they did not really weight it higher than other Qs that were available. So that is one finding. However, I did not really look for the effect if the temperature is varying, if that has an effect.
Okay, thank you. So my final question is about like because you based your conclusion on it to non-significant result. So did you like take any precaution regarding your sample size, like whether your sample size is enough to make those conclusions?
Sure.
About yeah.
I'm sorry, if you please finish your question.
Yeah, I finished. Yeah.
Okay. So for the participants, how to come up with the 30 participants, I actually, since I was trying to figure out if there is an effect on the judgment instead of judgment accuracy, my sample size of 30 was giving me a power of more than 0.8. And I actually did a pilot study for this for around 50, 60 participants to really come up with the number. And I tested for 7 Qs, 8 Qs, 10 Qs, and then try to figure out what is the best power to figure out the judgment accuracy. And the 30 participants, I'm sorry, not the judgment accuracy, but the change in judgment. So with 30 participants and novice judges, and this, the cardinality changing from 3 to 5, I actually had a power of more than 0.8. So it was enough for me to come up with the conclusion that I came up with in the end. However, if I change the hypothesis, then absolutely the number of participants would go much higher.
Okay, thank you.
Yep.
Harsh.
Yes.
Harsh, do you mind in the method section you share the models you are using?
Yes.
So I'm wondering, so as we can see here, there are one side is for the ground truth, one side is for the judgment, or let's say the predictions from our participant. So between them, there are a lot of X, which in this experiment are represent the cues you provided, and then there are some weight. So I'm wondering, is it okay for you to show like those W, I assume that they are weight, the coefficients being calculated? For example, do we observe interesting differences between the, let's call it pair of those weight? Can we observe some interesting differences between two sides?
I would have loved to share that if I actually knew, but I do not have this here. It's actually in my dissertation where I put in the whole model and actually the R file where I actually have all these numbers. So yes, you're spot on that. So the analysis, one analysis I tried to do that I answered in the last question also was the participants did not weigh any one particular cue more than the other, which means when I'm looking at WS1, S2, so all the weights from the participant side, none of them was actually much higher than the others, right? Significantly higher. But I did not actually compare the weight for WE1 and WS1 or WE2
yeah,
and
that's what I
WS.
meant. Yeah, because for example, the WE1 is representing like the ground truth. So it basically tell us like how important this factor can affect the actual electricity.
Absolutely.
So I'm wondering, can we find some interesting patterns, or like at that time your focus is on try to compare on the right hand side those weights, because basically based on your result it shows that the participant didn't take any one of them as like more important than the others. Is that what you find? And it sounds like because you manipulate the number of cues provided to the participant, so it means you run multiple of these models, and then each of them have a different number of X. Do you observe interesting differences among them?
Yeah, so those are very good questions. So number one, from the left-hand side, right? As I said, the way I figured out that these are the X's I should use in the final experiment, when I was doing the best subset regression, I looked at individual WE1, WE2, and those were the ones that have the highest weight. That's why those were chosen. But again, as I said, I did not compare E1 with S1. However, when I'm comparing X1, X2, X3, there was no stark difference when I got, even for a single participant, right? I had multiple regression equations, as you said, because every single time I'm giving them 120 questions. So that means I have 120 regression equations. And when I'm trying to compute a judgment model for each participant, funny enough, when I compared the judgment model for all participants across, it was pretty similar. All of them, actually, even their judgment accuracy was very, very close. So that is the comparison, and that's the analysis I did. But I did not go in depth into figuring out for individual participant, if I'm comparing within those 120 models that were created, if I can actually find any pattern. So I did not really do that.
Okay, thank you for answering my question.
Yep. So this is awesome. I wish you, actually, I'm happy that all of you were not there during my dissertation. Otherwise, I would have been there for like 2 more years trying to graduate. But these are excellent questions. And this is something that this work can be extended. And it's always great to hear that something you're doing can be actually extended and it has any use. So thanks for the question. I'll stop one more time if anybody else has any other questions before we move on. Okay. So how do we use judgment analysis in tech industry? So again, I'm only talking about tech industry. These are some of the information sources we have. You can consider them as cues. When you are using any product, many times companies collect data from you, right? The app usage data, sometimes you say terms and conditions, you put accept on that. And it's funny that today when I was reading preparing for this talk, I remember Dr. Proctor did one of the studies that Dr. Proctor was running with I think I forgot the student's name. I think Dr. Proctor would remember. The study was how when you are shown those terms and conditions on a screen, do you really even read that before you hit accept? Or what's the best way to showcase that actually people read those terms and conditions before hitting accept? Because I promise I've never read any terms and conditions. I've always hit accept. So when you are hitting accept, what sometimes the app is asking you is, hey, we'll be collecting usage data from you and we'll be using it for marketing and all those purposes. So when we hit that, when we hit agree and accept it, that is the usage data that we have in tech industry. Right? We also have log analysis, the number of times you're clicking any button in an application, we have that stored. Then we do user studies. So this was my previous job. I would actually run up a study. I'll have participants on the other side and I'll ask them, so what do you like about the product? What do you not like about the product? Can you use it in front of me? And I'll collect user data. The next one is customer satisfaction surveys. So sometimes when you, so one example I can give is sometimes when you're using Google Maps and you reach your destination, there's a small pop-up that shows up, sometimes one question with 5 smiley faces that, hey, did you reach your destination well? Did your map help you? And you have to select happy face, sad face, right? That is also a customer satisfaction survey. And finally, we collect market research data where we understand our customers, our competitors. So all these are information sources. However, we cannot use all of them to come up with a judgment because there are a lot of constraints. Technology is a big constraint and technology is expensive. Sometimes we do not have that technology to really collect that data. Sometimes time to market is very critical. We only have 2 months to launch the product, and the amount of data that we need to really come to a power which is respectable in terms of statistics would take 1.5 years of data collection, but we just have 2 months. The next is budget. We don't always have that money. Yes, Yashin, it was IPing study. Thank you so much. I think it was IPing study, but I'm not 100% sure. So, and the next one is various sources of information. The sources of information I showed, they are very few. There is so much information coming in from different sources that most of the time for us, it's not a problem of, oh, we don't have information. It's a problem of we have a lot of information and how to parse that information. That's the biggest headache. And that changes based on the industry you go to. When I was working in Schlumberger, we had to collect information for when a drill bit goes down the ground 30,000 feet. How many pieces of information do you think we can get when it's going down 30,000 feet? The amount of temperature and the pressure that's there in very close to the core of the earth, and 30,000 feet is still far, but it's still closer. How many pieces of information do you think we can get up, right, on the ground? Very few. However, for industry that I work currently, I work in Google Cloud, or if somebody, for example, is working on Facebook, so many people are using Facebook. So there's so many ways you can collect that piece of information, but do you really have time to understand, look at all that data, put it into a format where you can really understand and make a judgment? That's not always possible. So it is very critical we understand how many pieces of information are really required to make a good judgment, and what is the representation of that information that we need? Because changing the representation of information is very, very expensive. There are people who are data scientists who just do this. They sometimes are changing how the information is looking to make sense of it, right? And it's very expensive. So that is why we cannot use everything that's available, and we have to be very crunched up in understanding what's going on. Any questions about this before we move on? Okay, so now I would go very little bit into business, and I'll explain why the title was Producey instead of product. When I was starting out and I got my degree from Purdue, I did not really understand how can I apply what I learned in human factors into product. When we are launching a product, how can it be applied? So I would always ask this question to people, and one of my mentors would always say, oh, do you see why you can do it? So he would always, whenever I would have a meeting, they would just say, it's Producey management for me, because that's what they're trying to do. Can we really see why it's there? So that's why I had the title for you guys, that after I give a little bit of introduction, hopefully you can answer this question. When I ask you, do you see why it can be used and how it can be used? So let's go over a whirlwind of how user experience and a little aspect of human factors can be utilized when we are launching product. And it could be any product. I'm just covering a tech product, but it could be any product in any industry. User experience is a lot more than this, but for now, I'll just call this as UX or user experience, right? Mindset, what's the person's mindset and what is the process that they're applying? How they create a problem solution. We try to uncover and really understand our users. And when I'm saying understand the users, we want to understand their motivation of why they're doing. We want to understand their behavior, what they're doing. We want to understand their wants. What do they really want to do? And we want to understand their need. What do they really need from it? Sometimes the needs and the wants are very different. This is the critical part. As a UX professional, if you can figure out what is the problem solution, then you are gold, which means this is the hardest part to do, according to me. And the second, if you can figure out really what users are, that I feel that there is nobody better equipped than people in this room who can actually do that. Moving on to business and engineering, there are multiple things when we are talking about a problem solution. We have to think about a business need. We have to think about what's the market, what's the profit available, what's the technology we have, is it scalable or not? Is it only scalable for one city, or can it be used by more than 4 billion people currently? Right? And it depends on what industry you're working on. Currently, I work in an industry where we have to think about, can we scale it to 4 billion people or 6 billion people? Or maybe 15 billion people, not right now, but maybe after 15 years. Is it scalable? How would you maintain it? And when you have to sunset it, which means when you have to kill that product, how would you kill that product? Where it merges with the user experience is if you combine this problem solution and you combine these users, that's where the merger happens. Because if you have a clear understanding of user, you can understand that this is probably a business need. You can understand the market for it. You can see, will it be profitable? You can build the tech for that exact user. And you can also understand if it's scalable or not, and same for maintainability and whether you have to do a sunset or not. In product lifecycle, research also has a life cycle, which is very similar to at least what I learned when I was in Purdue. So I divided research into 4 parts. One is table research, which is just understanding what's already available, literature review. Next up is strategic research. You understand what your competitors have. Then tactical research. For example, if you are looking at Zoom in front of you and you are not able to find any buttons, you will do a heuristic evaluation or you will run a usability study. That's tactical work. Okay, you move this icon here. This is not discoverable, stuff like that. And the last one, I'm calling it evaluative, where it's slightly longer term, where you are understanding the deep reasons of why a person is doing what they're doing. And there are many ways to figure that out, like diary studies or understanding the sentiment and the satisfaction of our participant. How does this move with the product life cycle? Well, when we are building a product, we have these stages. We do planning, we understand the business, the vision, right? And the engineering, what's available. Then we do development. We make a project, we try to do project management, and we do engineering sprints. So we are doing 1 week or 2 weeks. We are quickly trying to come up with something. Then when we are launching, that's the time it coincides with the tactical study, right? Just before launching, we can do these evaluations to figure out, is the product good or not? And then when we are doing evaluative study, the business is trying to understand maintenance. For example, you did a diary study for a participant for 3 months and you realize that it's really hard for them to use. And then you are doing that maintenance loop for your product. So this is what I see, that the cycles work along very well. And if you have strength in each and every stage, and you have some understanding of business and engineering, I think you are set for success, at least in tech industry. So anybody has any questions, please go ahead.
I have a question. In your research stream there, it seemed like you just have subjective judgments. Is that intended, or is that entirely what the focus is on that?
So thanks for the question, Dr. Proctor. It's not always objective. So we also have, so is that your question, that I only have subjective research? Is that the
right? That's your strategic, tactical, and evaluative. Those are all what you have listed there is all subjective.
Mm-hmm. Yeah. So the answer is no, there are way more. So it's not always subjective. So we have a lot of objective research and we have a lot of instead of just understanding the user behavior, we also try to understand user actions by log analysis and quantitative data. And a lot of it is objective. Even when we are doing these studies like in-person interviews, a lot of it is also objective. It's only for this slide, I just put in some examples that we might be aware of.
Okay.
Harsh, thank you for your sharing. So I have a question. It's also related to relevant with this page. It's regarding, so right now we have the research and engineering, these two aspects. Then what do you think about whether the so-called design thinking can be aligned with this transition? Because I roughly look at this trend, for example, from planning to maintenance, from table research to evaluative, they somewhat match with the so-called design thinking that I have learned before.
Yes,
can you share more, like elaborate more about like what you think, your opinion about that?
Sure. So if you add design thinking, the roadmap or the life cycle for this, it would be very closely matched. Depending on where you're working, who you are working with, design planning comes up right from the start. So when we are trying to understand planning, right, that's where we have the designers trying to help us understand what do you really need, right? Where I say business vision, there is also a product vision, and that product vision is literally crafted by the design team to understand where is that product going to be, how should that product look like. When we are doing the development of, okay, let's build it, what is being built is actually being told by the design team and the UX team that this is what you need to build. If it's a front end, which means if it's a console, that design, it's the design team who's actually coming up with the elements of this is how it should look like. If we are talking about programmatic access, for example, APIs or software development kits, right? Then also design team is talking about the journeys, the critical user journeys, how a user will move from one place to the other place. And they are trying to define user goals and the tasks that the users need to do. So there are different ways you can do it. There are other models like job to be done. And there are other ones like critical user journeys or use cases, and then defining the personas and then understanding it. So all that is done in the strategic and development stage. And then when we are doing tactical, it's the same thing, heuristic evaluation, again, in the design thinking, that's obviously before launch. We are trying to understand and validate our designs with the customers. So that's where we have the design team coming in. And finally, the evaluative, we have benchmark studies that our design teams do, where they are trying to understand, okay, 1 year, this was the benchmark, we try to do it next year, how is that affected, right? And we are doing design evaluation. And again, all these cycles that I've shown, there is the boundaries are very fuzzy. It doesn't happen and we do one and then second and then third and then fourth. There are milestones, but the boundaries for this are fuzzy. So it's never that the table research is going on completely in isolation from strategic work, or design team is working completely in isolation with anybody else. So that's how, from where I see, design team actually works on this.
Yeah, thank you, Harsh. Especially you mentioned like several very familiar design methods, and hopefully our audience also got what you meant.
Okay. Yeah, I hope so. If you have any questions, please let me know. Just ping me if you have any other questions about what I presented. Please let me know if you have any other questions about tech industry, or if you think I can help you in any way. Please just shoot me an email. But any other questions that anybody have? Okay.
All right. Well, let's see. So I don't see any question in the chart. So yep. I think that's excellent. That's like it's a really interesting topic. So it's more, to be honest, it's more interesting. Compared to what I thought it's going to be. So I think it's really great. Yep, and then Harsh, can you just keep the slides for the contact on? So if anybody wants to reach out in the future or after this, so that they can have your contact. Yeah. So if if any of you want to kind of reach out to Harsh to talk about what a human factor engineer can do in the industry, or any other question regarding to product management or producing management, you can reach out to him. Other than that, oh yeah, and then I think it's a great presentation, and on behalf of the the HFES Purdue chapter, I really appreciate your time and your excellent presentation, and I hope we can find a time to reach out to you further with future opportunities.
Absolutely, it's always great to come back, and I'm so happy you guys are.
Yeah, I mean, I wish I can have you in person, in campus, right?
Yeah, no, this is always awesome. Thank you so much for your participation. Thank you for showing up, and thank you for awesome job you're doing at the Purdue chapter at HFES. And please, one thing that I have, my personal goal is try to get as many people from Purdue in Google or any company I'm working for. So if you have any questions, please feel free to reach out. Just send an email, connect on LinkedIn, anything. Would love to help.
All right, definitely. And if you have any kind of opportunities that you want me to share with the Purdue community, you can always reach out to us. And then, yeah.
Sure, absolutely. And thank you everybody for attending. And thank you so much, Dr. Proctor. I think it's probably a waste of time for you, because I have given you this presentation 10 times before I actually presented it to my committee.
Well, not really, but thank you for giving it. Yeah.
No, thank you so much, everybody.
All right, thank you. Bye.
Bye.
All right. Thank you, everyone.
Thank you.
Bye. Thank you.